So Unit 6.1 is about using and interpreting line graphs. So a bit of revision from last year. When we're plotting points on the Cartesian plane, the horizontal axis we label the x-axis, and the vertical axis is the y-axis. So if we want to plot some points on this Cartesian plane, the coordinates that we're given, the first value, remember, is the x-coordinate, and then the second value is the y-coordinate. So to plot this point 4, 3, we've got to go to our x-axis and find x equals 4. So we move to the right, find x equals 4, and then we've got to go up or down to y equals 3. So we've got to go up to y equals 3, and we can plot that first point there. Now, the second one, 2, 2. So again, on our x-axis, we've got to find x equals 2 here, and then we've got to go up to y equals 2. So we can plot that point. The third one, 0, 1. So on our x-axis, x equals 0, so we don't need to move along the axis. We're at the origin, and then we've got to move up to y equals 1. So that point 0, 1 is there. Negative 2, 0. Again, on the x, we've got to move to the left this time to find negative 2. And then we don't need to move up or down. We're already at y equals 0. So that point will be there. And then the last one, negative 4, 1. We'd move to x equals negative 4. And then we've got to move up or down to find y equals negative 1. So we would go down to here. So you might have noticed these points that we've plotted are forming a straight line if we connected them. So we could connect them all with a line, and this sort of line graph where it all forms a straight line we call a linear graph. So any point on this line carries two pieces of information. So we've got an x-coordinate and a y-coordinate. So this line is just a series, an infinite series of points that are all joined together. So any spot on the line, we can find an x and a y coordinate. But we'll be looking at a few different sorts of line graphs in this exercise. They won't just be linear graphs, a straight line. We might have graphs like this where there's different sections, different parts to the line graph, where the slope can change, might be going uphill or downhill, and the gradient, the steepness of the line, can change as well. So if we have a look at this graph, on the x-axis, now we've got time. So as we move along to the right on our horizontal axis, we've got time increasing in hours. On the vertical axis, we've got distance from home in kilometers. So as we move up on our y-axis, we're increasing the distance. So let's have a look at the question that goes with this graph. Selena leaves her home to go for a walk. The following line graph shows her distance from home. Describe what information is being shown on the graph in section A, section B, and section D. So let's have a look at section A. First, she starts at the origin. So her distance from home has to be 0. And then the graph is moving up. So she's moving in the positive direction on both the horizontal axis. So time is increasing and her distance is increasing. So she's moving away, she's walking away from her home. So we'll say she's walking away. But what about section B? So at section B, her distance is not changing. She's not moving on the vertical axis, not moving up or down. Time is increasing. So time is increasing along the horizontal axis, but distance is not changing. So she's not moving at all. So she's obviously just stopped to take a rest or something, but she's not moving. Then section D. So in section C, she started moving again, started walking further away from home. But then in section D, the direction of the graph changes and she starts moving in the opposite direction. So her distance goes from 2 kilometers away back to the origin, to 0. So in section D, she must be walking back home. Okay, B. In which section was Selena walking the fastest? So if you think back to when we were doing rates, speed is distance over time. So when you're moving quickly, when she's got a fast speed, she'd be covering a lot of distance in only a short amount of time. So let's have a look at roughly how much distance she covers. In section A, she's covered, say, probably about 1 kilometer in a short period of time. Section C, again, she's probably covered another kilometer, but in a longer period of time. And then in section D, she's covered 2 kilometers, because she's gone from 2 kilometers away back to 0 in, again, a pretty short span of time. So she must have been moving the fastest in section D. In which section was she walking the slowest? Well, she wasn't moving at all in section B, but where she was walking the slowest was in this one, section C, because she's covered about a kilometer in quite a long period of time. So that's when she was walking the slowest. And the final part, what was the total distance that she walked? Well, she started at home at 0 kilometers, then she's walked 2 kilometers away from home, but then she's turned around and come back to 0. So she's walked 4 kilometers in total. Okay, final question. This is question 3 from the exercise. So you might want to pause the video before I give away the answers, just so that you can have a think about it as well. But the question says, the following graphs show the distance Ahmed is from his home while out walking during different time intervals. So we've got 6 different graphs. They've all got time on the x-axis and distance on the y-axis, and we'll need to match up the graphs with different situations. So the first one, Ahmed is walking away from his home. So he must have started at home at the origin, and then he's walking away. So it must be this one. He's starting at home, and then he's walking away. As time is increasing, his distance from home is increasing. So it's A. The next one, Ahmed is stationary, not walking. So remember, if he's not moving at all, then his position on the vertical axis on distance shouldn't be changing. It should just stay the same. So it must be B, this one. So his distance is not changing. As time is moving along, he's staying in the same place. So he's stationary. So that one is B. Next one, Ahmed is walking away from home, stops for a rest, then walks home. So he's at home, he's walking away, he stops and then walks home. So he'll walk in the opposite direction. So it must be this one. Walks away, stops for a while, and then goes back home. Ahmed is walking directly home. So he starts walking back towards his home straight away. So he must be away from home. So he's not starting at the origin. So it must be this one. He's somewhere away from home, and then he heads straight back. Okay, Ahmed is walking and stopping at equal time intervals. So he's walking and stopping. So we're going to look for where there's a gradient, but then it becomes horizontal, levels off. So this one, he's walking away and then stops. Then he starts walking again for a certain period of time. He stops again and then walks again. So you can see they're pretty much equal time intervals. He's taking the same amount of time to walk, stop, walk. So it is F. The last one. Ahmed is walking away from home at first, then stops and returns home immediately without stopping. So the last one we've got is this one, D, and does that match up? He's walking away from home, then stops and returns home immediately with no break. So there's no horizontal section. He just turns around and goes straight home.